My name is Oren. I'm coming from Panama. I'm working in a company called Top Manage. We are SAP partners. We are working mostly in the .NET area with a lot of .NET products. We have some Java and Jira. And our products mostly involves around SAP. What I'm gonna give a talk about some kind of a war story that I had. Moving a legacy code that's written imperatively, refactoring it actually, and I try to refactor it in the most simple way and the fast way because I had time pressure. And it naturally came to a Monadic interface. That's what I will try to show. How was my thought process through that? So just to give a little bit background, the program that I'm going to show, it's a program that it's an application that we are using in an area, the free zone of Panama. Our client uses SAP, and in the free zone of Panama too, and they need to register the program through FTP to the government of Panama. They need to register the transaction that they are doing in SAP. So we built some program to make them easy. Before that program, they were doing it manually, like with paper. So this program has like, I think 10 years, even more. And the code, while it was written fast. The people that were, it was not thought about, designed so carefully. It's imperative code with a lot of if, a lot of for, a lot of repetition. So I got a task to add a new database connection. We had a big client that wanted to use a new SAP HANA. SAP HANA uses a new connection, new database connection, and I had to refactor this up to use the new database connection. So I was trying to create something that will be used for a longer time. So I'm gonna jump to the code, to the starting point, so how it's look like. You guys can see? Okay. So this code is imperative as it can get. So you have a SQL connection. This is actually pretty common to use. A lot of people that's starting to work with C# will do the same thing. We'll do new SQL connection. We'll do connection open. We'll do some command that gets this connection and execute a reader and then read everything line by line. And then we'll do some more stuff. In this case, it's a little bit worse because there is some static class with static property that I need to set for the entire application. But I guess that's fine. So I had really time pressure on this. So scanning the entire code, I figured out that what I will have to do is to change the SQL command to HANA command, which are both inheriting from the IDB command. So you have inheritance for the IDB command, IDB connection, and there is a provider when somebody wants to provide its database implementation, you can just override this IDB connection. So I was thinking how I can make it faster to my end goal. So the first thing that I thought about is just let's wrap around static classes. So my first iteration on this was something like this. Let me go up here. So I will have a connection. So now I will have two types of connection. I can have HANA connection or SQL connection. So I will just provide it here. I will create a connection base. I create an enumeration to tell me which implementation I should choose. And this will become later the DB state that I will carry in my monad. So, but first, let's just do it simple. Static class, get a connection, tell me what is the server platform, give me a connection string, and I will give you back a connection. And then I was thinking about it a little bit more, and I would say, okay, we should give more responsibility to the compiler. So I added a DB connection string class, which, in order to initialize, you give a connection string. Let's see if I can do pick definition really quick. So in order to initialize, it will do some check on the connection that it's valid. It will switch in between, will create a correct connection string for HANA, correct connection string for SQL, and return you the DB connection. This was pretty intuitive, and okay, this is nice abstraction. This is, by the way, how do I build a connection string based on the platform. And then, so, okay, what is the next step after this? The next step, if I'm looking at this, now it's the command. Now, the command, the intuitive way to implement it with a static class is to get everything into a static class and return a reader in this case. So my first try was like this for the command. Let's open it. So I was saying, okay, let's, instead of giving a connection, well, I starting with a connection string actually, and later on I made the type more complex, but at the start I just fed the entire thing that I need into the static class, and which include the DB state that later become a little bit more complicated. Right now, as the first thing, it just could contain the connection. And then it choose in between the type of the, based on the type of the connection, it will choose either a SQL command or HANA command. And then if there is a transaction, if the DB state contains a transaction, it will feed it to the command too. Then I created here parameters of DB parameters, which will give the user more nicer way to define the DB parameters. And by defining the DB parameters, which you cannot see really, I will move it a little bit. So DB parameter will have a definition for each of the possible parameter unified in between HANA and SQL. And it will give me something a little bit better than the interface that I had before with the DB connection. I can force now, instead of receiving object, I can force the type related to this parameter. So this is more or less the DB parameter. So again, I can use this DB parameter that we're going to be fed to me directly into the command. So the command function knows only about the command right now. But I have a problem here. I have a problem because I actually not doing a lot here. I have this DB state. If I actually just using this, I will have to do the same. I will have to prepare the entire thing, the entire connection, the transaction, and open them and close them under. I will have to prepare it beforehand. So I wanted to keep myself in a static classes as much as I can without involving state long run, like state that will stay in an object. So I push the DB state as a carry. So I use, if you see the function above, the command above, which getting overwritten here, it will just return the DB state as a function to be used later. So now I was starting to use my knowledge from Haskell, and maybe I could encapsulate, maybe I can make this DB state to be carried on by chaining the function. So I can now return this function, and another command return this function, and another command will return this function, and then I can do some bind. Maybe some bind or some way to compose them. So I did one more thing for the command. I did db command for file. db command for file will help me in a big queries when I want to define a couple of versions of this query, just to put it as embedded file into the assembly, and I will be able to retrieve it. So I did some kind of convention. So you give me a name of a file, and I will search based on its extension for the type of DB that it is. So I don't need to repeat myself. I don't need to repeat myself and switch again in between what I am. So yeah, command for file is just based on the DB connection. It will choose the extension, in this case SQL or HANA, and we search it in the assembly for the embedded resource for this file. So big queries, I can just bring in from a resource. So this is all for the command. So yeah, before I go to here, let's see if I can. Okay. So that's fine, but the function that I brought from the command that might be changed, it's not exactly what I want. It's not the function that I actually want to compose. I want to compose a function that will carry the DB state. So for that I did then. I don't want, because the function that returns a command returns a command. I want it to be for any generic type possible. So I did an extension method then that work on this function that gets a DB state and return a DB command, and get another function to transfer the command to T, to whatever T you want. So this will be whatever the result of the database. So it's a function, so it's not getting evaluated. And now I have something that I can chain. Now I have something that I can compose. This will build something that's called queries. So the queries is just, this is the actual monadic type. The queries is actually a function that receives a DB states and return a value with the state. This is actually the state monad here. So that way I get to hide DB state from the user. He doesn't need to know about it anymore. Now I will able to map into the T or flat map if I need info to play with the context and bind another queries of T. So then those are the implementation. So then those are the implementation of the actual monad. So I have some returns. Some returns they taking like new queries will just take whatever the state is and keep moving it forward and return a unit as the value. You have another type of return that you can, when you ask a specific type as the return value, without anything, you will get the default one. And when you want to return some type, you have this function of T with this type. So, yeah, let's close. This is the return. So before the bind, let's do the functor. So the functor type for this will do what a functor expected to do. And I will override the link queue extension because people in C# will expect link queue. So I have a map and an override in select that will just take the inside of the queries and return a new function. So I'm just working on the value. I don't care about the state, but I'm not running any computation. I'm chaining another function. That's the meaning here of a map. I did another thing. I will go to it later. I did 2 layers mapping, which is kind of monad transformer map that I can have a queries with option in it. With option, well, in this case, in C# it's option of error. Option with a type and an error, it's either. Sorry. While option with only one type is just maybe. So it just, in this case, it just go down to level and will give you the value if there is a value in the maybe, or will continue carry the error if it's an error. And all of this in the queries context, which means that the computation will just continue without evaluating right now. So now, yeah. So after the functor, usually comes applicative, but we will skip this one and we'll go to the bind. The bind here, I use the flat map as a name. And I did the same thing with flat map with an arrow to go down the 2 layers if I need. And I override the select many. Both flat map just use the select many. The select many in link queue, in order to get link queue form working, you need to override the select many extension method. And they add another step Usually in Monad, we just have the function that go from the value to the Monad. In select many link, you need a result selector. That what happens there, you have the type that you are trying to run on. You have the function that will go up to the monad. You need to extract the value from this type, feed it to this, getting the monad, extract this one, and run a selector on them to get a return type. So it's just another layer. Which, if you'll see in the flat map, which is here, I'm just using this selector is like, ignore the old value, return me the new value, which is what we expect, more or less. So this is the bind. Now, because I created more specific, so in C# you don't have type classes, and you have to be more specific in your implementation. So like I did flat map with error, I will have to do like I could do catch, for example, that will search for this error and will handle it in a function and will return another thing. Yeah, and then I have a couple of extension methods, like if I want this computation not to run, I can add on top of it run if, and decide based on a predicate if I want to run this query or I just want to ignore and return, continue with a default value. Or I can run another one that will say if the predicate is not valid, just return an alternative value. I have some state manipulation, but let's go a little bit about the workflow. So now I could do stuff like this. I could do command that receive two types of query, if I want. One for SQL, one for HANA. And then we'll do something with the command in order to return any T that I want. I can just initialize queries with value with no database thing. And I can chain them in a link queue. But this is just chained function now, and they don't have to run until I do the run command. The run command is what executing the actual computation and returning the inside value of this monad. So the run command, now I can do on this computation, I can carry them wherever I want in my code now. And I can either do run on them and run the computation and just return a value. And inside it, I will do a connection with connection that will do all the bookkeeping for the connection for me, that I don't think the user should know about it either. It will just create a connection, we'll open it and dispose it when it's done. Or I can do run with transaction, which will do the same thing. Let's see, run with transaction. Run with transaction will do the same thing, getting the connection, but adding a transaction too. So the old code that I had will becoming something like this. So I do db command. Let's move it to this side completely. With 2 queries. Then I executing the reader. And then I have another extension method that take a reader, because this computation now will dispose everything after the run. So the result of the reader won't be available if I will just return the reader out of the run. If the reader was the T to be returned out of the run, the reader could not access its result. In some cases, it's weird. I guess in some implementation in HANA, it still can be. In SQL, they close it. But it depends if they close the connection or not. So I did another extension that, in order not to mess with it, it's called read row, that will take this reader and will convert it to a dictionary. And then it doesn't matter if the connection afterwards is open or not. And then I can keep working on the type. I'm converting it to a dictionary, not to static type, in hoping that the next phase will take this dictionary and create from it more static type to work in the code if needed. So this, yes?
I want to ask a question about the database in HANA. Did you know that they had very similar operations? Like you mentioned, the database would close the connection, but HANA would keep it open sometimes?
And this I had to experience while it was running. Mm-hmm. It was a fix after it was running, actually. Yeah, I had to take the quickest approach to market here, so I had to go for a couple of guesses.
Right.
So.
Yeah, I just wondered how much planning you were able to do. Like how much knowledge of the system you had before you chose to go on this Monadic approach. But it sounds like you were like, this should work. Let's see if I can make it work.
Yeah, that's what I'm trying to show, that I just really wanted it fast to market. So I started with static methods, like the way with the DB connection. I started with static methods, and then the state came, and I want to eliminate this too. I want to hide it behind the methods, but I don't want to use state.
Right.
So then the monadic approach came in handy. Yeah, it came in handy. So I will show you the other part that is more complicated. So those query, this is the simple query. This application was full with those query. Of course, I will rewrite the entire application if I could. And it won't look the same. But the client that we had is a big client. It's one of the provider in SAP of Gucci. And we had a time limit on this. Sure. So you need to choose your battles. So this is another part that was a lot of variables. Each value here is an object, so I can feed to it whatever, and if I don't feed the right type, it explodes to the parameter, and it happens a lot. I have a command. Before I had something that get the query to, but it was using this static class, static property thing. So I have a couple of queries that needs to run after the other. So I have save is Deform, and there was another one, maintaining containers. Let's see. So save is Deform. Each of them have try catch for the thing, another for item, save items. And they have for each of this thing in this data adapter, for each row in the data adapter, and only you need to choose only specific one. And you have more containers, and then you need to delete rows. So with the new interface, let's go straight, it will look different. Now it's just, this is the new C# local method thing. So I can create methods inside the function now. In the new C# you can do it. So this one became a method that only care about this query now. The other if, for, should run, not run, will be outside. And this is the save. And I'm using now, this is something that I was able to push to the compiler, is the types forcing the C# type on the parameter that you put to them. So I can say, I have a DB parameter and varchar that called like this, and this must be string. I have DB parameter which is decimal, which is insurance, and this must be a decimal in C#. So I have all of those. Now the items coming straight after, because it's only the items, and I can carry there wherever I want because it's not evaluating the computation. All of them returning an optional instead of the try-catch that they had. Now they are returning an optional. The optional is handled right here with this catch extender method that actually wrap these queries in a try-catch and will give it to the handler to handle the exception and return it as actual return type. So I can carry, I don't need to explode the computation in the middle. The outside program can decide what they want to do, if they want to stop the computation or not. Just giving back the either. The same with the containers. And now I can just combine them together in a monadic way. And with the two-layer flat map, combining them together. So, yeah. And then the last one need maybe not to run. So if it's not running, then return this default value. I have, then it added to do the delete rows and another query. This, until here, it's all the computation bind together. Now, I could carry it, I could continue combining to it, or I can just decide to run it here with a transaction and give it that now the DB connection data is, well, at least I made it read-only. It's still a static class and static property, but it's read-only. I'm passing it here in order to execute. Yeah, so this is more or less that. So I open source this library. I open source this library. This library is really, really simple. Right now it's really crude, but anybody is welcome to add to it, and if you think something could be better, can do a pull request and say anything. Yeah, that's my talk, more or less. Any question?
I'll ask a question. Did you have any tests, like to exercise this monad, or did you just rely on the compiler?
It's becoming a lot easier to test it after moving it to this interface. But I didn't add a test. I just running it in this workflow that you see there, and just running the actual application to test it. Most of our programs are fully tested. I had another library that is written 80% with static methods, like in C#, and it worked pretty good. And this library is from top to bottom tested. And it was really trivial to test because everything is a static method. Yeah.
And how long did it take you to do this refactoring?
I think like a week. Yeah. No, well, week the big thing, but then all the queries actually had the string of the query. The problem I had almost.
Queries are going to be different, right?
Yeah, the query was not. Yeah, and the queries, sometimes somebody forgot something in the string of the query, and this had to be adjusted a little bit after. But this worked almost without any changes. And the code was reduced because of this, because now you don't need this if boilerplate, and you don't need this for boilerplate, and you don't need so many stuff. It reduced it. It is simple, I think. It just came out from playing with iOrder function and carrying. You start to carry this function. The key point is like the carrying of the DB command to a function, and from there the road is really close to a monad. Like now, just bring a tuple of the value and the state. And now just create another function with this. So now you need to compose it.
Did you have any colleagues? Like, you know a little bit of Haskell. Did you
Yeah.
have any colleagues that have to also share this code that maybe don't know the monads? Were they?
Yes. And so this is a good question. And right now, this is working in production. This is working for this company. They are happy. Everybody happy. My colleagues did not need to go and touch the code yet, but I hope in some point they will have to, and they will see a new technique to use. Yeah, that's more or less it. Yeah. I might use this technique even more in other stuff.
This is great. I love seeing these examples of bringing that functional programming, even when it's not like Scala or Haskell, but you're taking these ideas and bringing it back to a generic language and a generic problem. And I think this is a great thing to remember, that it's not only just possible where it's easy with like Haskell and Scala, but you can do it anywhere.
Yeah, that's people are saying, well, C# is missing higher kinder types, so you don't have type classes, so you cannot do monads. Well, some of them think like this. It's usually people that just starting, but yeah, it's actually becoming. I was saying when you get type classes, you get this abstraction of the bind, which is fine. Now you can call everything bind, and you have the do block that will take bind, which is fine. The bind defined the in between the context and the value. The bind is, when you implement bind, you implement the in between the context and the value. So this implementation described by bind for every type might not be as descriptive. Like when you have a specific, you might, if you are able to change the name for each type, maybe it will be more descriptive for what is in between the monad.
Right.
So Yeah, but you cannot get both. So you want abstraction with one thing that will get them all. You need one name, but yeah. So.
Well, thanks for sharing this. This is great.
Thank you.
I really appreciate that.
Thank you.